Aloha, Rich Halverson here. This is ITS128, and today we're going to go over. This is week 4, and so we're going to go over chapter 4. It looks like. Let me share my screen. Share 2. All right, so I like to just click on the playlist to make sure I'm in the right place. And oh, okay, yeah, video chapter 3. Okay, so I guess we're, oh, right, okay, I know where we are. I bet I haven't done too many of the labs yet. So I'm gonna save those for later or for a different video. Let me just these labs. So okay, so we're starting chapter 4. So let's go ahead and start chapter 4. I think I can click right here. And let me chapter branching. All right, so this is where we start putting logic into our programs. We're able to test things. Normally we maybe test some inputs, and based on whether certain conditions are true, we'll do one thing, or we'll maybe do something else. And so that's what we're going to talk about today. And let's see, almost every section's got a challenge. Okay, so so the branching concept is pretty simple. For example, let's say people familiar with restaurants may be familiar with steering people to different size tables based on group size. And so, for example, if you come in and you're a party of 1, you'll get seated at the counter. Else, if you are a party of 2, you will get seated at a small table. Else, if you're a party of 3 or 4, it looks like we'll get seated at a larger table. Excuse me. I should finish clearing my throat before I start teaching. All right, so anyway, that's like the concept. Here's flowcharts. We used to do everything in flowcharts, but now flowcharts aren't that handy, and we really kind of rely on the indentation of your code. And you should be able to sort of visualize a flowchart in your head when we do this. But flowcharts are good for describing the logic very early on. But we don't use flowcharts in our documentation or anything. All right, so here we see the branch concept. Let's say it's a hotel rate, but you read in what the user's age is. And if the user's age is greater than 65, let's say, you get, looks like $20 off. Otherwise, if it's false that the user is greater than 65, you don't change the hotel rate at all. You just you skip over it. Okay, so that's an if-then. Here's an example of computing the absolute value. So you read in a number, and if the number is less than 0, then of course you're going to do something to it. In fact, you're going to take the negative of it. If the number is 0 or greater, you're not going to do anything, but the value you read in is fine. So you skip over the step. So click through to make sure you understand that. Like, for example, here, if the user is less than 25 years old, they pay $4,800. Otherwise, they pay $2,200. And so if the user is 18, what price is output? Well, it's going to be $4,800. And so you just go through this, make sure you understand how that works. You can have if, then, else, or if else. So if it's true, you do some test. It's either going to be true or false. If the test is true, you do one thing. If the test is false, you do a completely different thing. And then you meet up again and continue on with what's after the if. So that's if-else. And so make sure you understand that. You can sort of cascade these if-elses into if, else if, else if, else. Instead of just if, else, you can do if, else if, else if, else if, else, like this. So you're you read in some variable, some number of years, and if the number of years equals 1, you do one thing. If the number of years equals 25, 25 years, you do another thing. If the number of years equals 50 years, you do a third thing. Otherwise, if it's less than 1, or if it's between 2 and 24, or between 26 and 49, or greater than 51, then you just say congrats. You do a fourth thing. So that's an example of a use of an if, else if structure. So it's kind of like this: if x equals y, or if x equals -1. Okay, this is, got to keep my languages straight here. So this is how you write if, else if in Python. No, it's not. Okay, okay. Anyway, this is still logical. All right, so let's do one of these challenges. Let's start it up here. And okay, so you read in the number of apples. You start out with the number of apples equaling 0. This doesn't change or anything. This is actually quite confusing that they have this here. But you start out with an empty object that's got which stores the value of number of apples, and here we set that equal to 9, and then we do a test. Is it less than 6? If it is less than 6, print out a C. If it's not true that it's less than 6, in other words, if it's 6 or greater, then print out an E. And then then when you're done printing out either the C or the E, then you come back around here and you just print out a G. And so I guess the result is, because 9 is, this is not true, so you're gonna do the false case, which is E, and then you're gonna output the G. Yeah. So that's pretty easy. Let's do number 4 here. Okay, so we start out with a variable called num tickets, and the first thing we do is we set num tickets equal to 6, and then we're going to do these tests here. Is num tickets less than 5? No, it's not. So we go down to the false case. Is num tickets less than 10? Oh, yes, it is. So then we take the true, and then we print out an F. So I'm going to put an F there. And then we come back around here and go down and we print out an R. So I'm going to print an R here. Oops, an R here. And is this right? Yes. Okay. So another thing we do, what's very common, is we detect equal values with branches. We test, is something equal to this? No. Is it equal to this? No. Is it equal to this? And that's what we looked at earlier. Here is how we do this in Python, in coding Python, is we use this double equal sign. So this thing starts out, we're setting a variable called hotel rate. We're setting that equal to 150. And then we ask the user, we print out, enter the number of years that you've been married. You input that in. You input it in. You convert it to an integer, and that gets stored in a variable called num years. So if you enter in 50, then that's what gets stored in num years. And then there's a test here: is what we stored in there, is it equal to 50? If it is, print this out, okay? If the number of years is not equal to 50, then you skip this. You skip it and you just go around it and you go down here. Okay, so so if it is equal to 50, you print this out. And then you recalculate the hotel rate. So now it's a smaller hotel rate. Oh, look, it's half the price. And then when you're done with this section, you go down here, you keep on going. And then when you print out the hotel rate, you see the hotel rate will be half the price because of this. All right, so, make sure you understand that. This sort of shows how it works. The first thing we're going to do is store that there. And then we're going to ask the number of years married, and the person types in 50, and that gets stored there. And then the number of years is equal to 50, so that it's going to do the indented part, and so then it prints that out. Yeah, see here we're doing here. Oh, look, this down here, isn't that nice? Wow, these animations are quite the thing here. Okay, and then we're done. Yes. All right. Very good. Got my points. So make sure you understand this. Bonus. What is the final value of num items? Well, bonus value is equal to 10. So when this condition is evaluated, it's going to be true. So since it's going to be true, it's going to do the indented part. And what does the indented part do? It adds what? It adds 3 to whatever num items is. And that's what value of num items is. Well, it was 1. We add 3 to it. It becomes 4. So I put a 4 there. And lo and behold. All right. So there's the equality operator. And then there's the opposite of the equality operator. And that looks like this. Okay. This exclamation point in front of something usually means not. Okay. So make sure you understand that. And here's the else. Here's what an else, if-else statement looks like. We have the word if, and then we have the condition, the expression, which is going to evaluate to true or false. If it's true, it does the indented part. If it's false, it does not do the, it does, if it's true, it does this indented part. If it's false, it instead does this indented part. And then it goes on. So make sure you understand that. In this case, since bonus value is equal to true, is true, bonus value is equal to 12. Then it does the true part, which is num items equals 100. And so that's what the final value of num items would be. All right, do these participation, you gotta do. You're supposed to type this if statement in. See, this tells you auto indents, but it says it's not checked. So if user age equals 62, item discount equals 15, else item discount equals 0. 62, not 63. Does this work? What it didn't like. Oh, I forgot the code. never mind. You know, just before this class, I taught the Python course, and we're using this exact same textbook, except for we're teaching anyway. That's why I got so it looks better. It looks like that. Oh no, I'm sorry. Scratch that. If you two weren't here, I would stop the video and start over again at a previous point because I just made a big mistake here. But anyway, it should look like this. We do need to indent. We do indent 3. That's what that is. 1, 2, 3. We'll check it. What does that mean? And then we do this, and then we do this colon 1, 2, 3. Well, consistent. Okay, so if the user age is equal to 62, okay, then set it equal to that. If the colons matter or no semicolons, okay, let me see if that's right. Okay, sorry. Okay, great. So that's all you got to do for these. Just type in the right Python code. If num players does not equal 11, then 1, 2, 3 execute team size equals 11 spaces in there. Otherwise, else 1, 2, 3 team size equals num players, num underscore players, yeah, no matter the value of number of players, execute teams. Okay, so then no matter what the value of num players is, team size equals 2 times team size. So first we set the, okay, great. If the number of players does not equal 11, then team size equals 11. Otherwise, team size equals number of players. Then no matter what the value of num players is, team size equals team size times 2. Okay, is this right? Yeah, great. All right. Oh, good, a challenge. Start. Number of puppies equals 4. If number of puppies equals 6, then print out a C. Otherwise, print out an F. Well, it looks like I print an F. And then print out an H. Oh, sorry. Again, it's the language thing. Okay, let's do it again. Oh, it's just like gonna let me fix it. All right. Basic if-else. Write an if-else statement for the following. Okay. Start. If user tickets equals 14, award. Oh, wait. If user tickets is not equal to 8, I've got to read this, not this, is not equal to 8, is not equal to 8, then execute award points equals 10. Otherwise, award points equals user tickets, whatever user tickets is, not 8. So I'm going to say this. All right. Okay. Yeah. Okay. I'll do this one too. What time is it? Yeah, let me just quickly do the next one. Write an if-else statement for the following: if the number of if num difference is equal to minus 16, then do this, else do this. Oh, okay. All right, very good. Okay, this is multi-branch, and here in this example, you only care about 3 or about okay, so it's like how many years have you been married, and it's going to say it's going to say nothing special. It's going to say nothing special unless you had entered 1 year or 10 years or 25 years or 50 years. If you enter one of those 4, then it's going to print out some special message for you. Otherwise, it's just going to say nothing special. Actually, it should say that's great or something like that. But anyway, so this is a similar thing. So that's how multi-branches work. Let's say num sales is equal to 2. Well, it looks like it's going to do this one. So employee bonus is going to be 5, I guess. And okay, where are we? This is 4.2. Guess we did the challenge already. 4.3. Ranges using if-else-if. Okay. So this is another very common way to use these if-else, if-else-if, elif, else if. Where's the Python? Guess we don't see the Python yet. Anyway, so here we are cast sort of this else if, and the thing is what's nice about this is once we started off, then really here we're looking at a narrow range, and here we're looking at a narrow range, and here we're looking at a narrow range, but we only have to specify the upper limit of that narrow range because the lower limits have been taken care of already before we get to this if statement. So here we say if the range is from 0 to 5, it's going to do what's inside here. It's going to be no teams. If it's 6 or 7, because if it's equal to 6 or it's equal to 7 but not 8, then it's going to be play of the U8 team. And if it's 8 or 9, it's going to be play of the U10 team. And if it's 10 or 11, it's going to be play the U12 team. But if it is 12 or greater, then it's going to be no teams, just like if it's less than 6. So that's how you're able to narrow down a band. And so you say, you divide it up and how you take care of each category in the range. So that's what the structure looks like. And so you have to get used to, this is going to be this one, and this is going to be this one. See, we don't have to specify the 10 part because that's taken care of up here. Anything that gets down to here is going to already be 10 or greater. So anyway, that's the idea here. All right, so make sure you understand that. Here's a challenge, a decision to detect increasing ranges. Okay, indicate the range covered by the following decision. Assume X is a non-negative integer. X is a non-negative integer, and if X is less than 20, then that means we're saying the range is covered from 0 to 19. Yeah, because it's an integer, so it's and okay, so is this right? Yes, 0 to 19. It's pretty easy. Here is, you can go through this. It shows what a flow chart would look like if we were to express this, where if user age is less than 16, do this. Else, if the user age is less than 25. In other words, if it's between 16 and not quite 25, then you do this one. If it's 25 or all the way up to 39, you do this one. If it's 40 or greater, then you do this one. So that's how it looks like in a flowchart. All right, let's see what this does. Flowchart decision. Okay, so type the range for each given branch. Start it up. Assuming X is non-negative integer. So X is a non-negative integer, and we are outputting Y equals 1, or we're doing Y equals 1. So that would be this range right here. So how do you get to Y equals 1? Well, it's between 0 and 10, looks like. Can't be 11, because otherwise, if it's 11, this is going to be false. Then it's going to go down to here. So this is going to be between 0 and I would say 10. Yes. And the rest of these are the same, just like that. Okay, what's 4.14? Detecting ranges with branches. So here it's, what was it here? Yeah, it's still branches. Okay. So this just talks about relational operators, and so you know what this means. This is if A is less than B, it looks like that, and so if X is 3, then this is going to be true. Is X less than 4? Yes, it is true. Is X less than 3? No, it's not true. It's equal to 2, so it's not true. So this evaluates to false. This evaluates to true. And so on. There's less than or equal to, greater than or equal to. Make sure you understand what this means. Indicate whether the expression evaluates to true or false. X is 5 and Y is 7. All right. Is X less than or equal to 7? Yes, it is. 5 is less than or equal to 7. So that's true. See, is Y greater than or equal to 7? Y is 7. And so 7 is equal to 7. So that would be true. So that's how that works. Here we're supposed to type in the operator. Is numdogs greater than 10? So it'd be this. And here is how we write them in Python. This is how we write them. This is how we write these, these if these if statements, these branches in Python code. This is if user age is less than 16, you put a colon there, and then this is what's inside. And then the else if, that's written that way, elif, and then just else at the end. So this is if the user age is less than 16, then you do this. If it's between 16 and 24, it'd be this. If it's between 25 and 39, then you do this, and so on. So make sure you understand that. Okay, here's a challenge, some challenges. What time is it? 2:30, right? Enter the output for the branches with the relational operators. All right, let's start it up. Num-egs equals 6. If 6 is less than or equal to 6, yes, it is. So print an A, and don't do a. Oh, and we do a line feed. We do a line feed because it's Python, and then we print the K. So I just do K. We do this one, skip over this one, and do that one. Is that right? Yeah, okay, good. Let's do this one. Num puppies equals 6. Is num puppies less than or equal to 5? Why, no, it's not. So we do the else case. Print D. Okay, there's a D. Got to print the return, and then print K. Okay, I'll print K, and then return. All right, it's that easy. Okay, what's this one? Basic if-else expression. Write an expression that will cause the following code to print less than 20 if the value of user age is less than 20. If start if this, no, not really, it's less than this. Is that right? Well, while it's thinking, let's look at the next one. Write an expression that will cause foot or more to print if the value in num inches is greater than or equal to 12. You know what's going on here? Oh, well, thank you. Sorry. Okay, so if num inches is greater than or equal to 12, that goes right here. Paste. If num inches is greater than or equal to 12. See, it's also nice that they tell you this, just because you should be thinking this way when you're testing your code. And so this is where it sort of switches over from greater than or equal to is true. See, it's, oh no, I'm sorry, greater than or equal to 12. We'll see. So greater than or equal to 12, and this is not greater than or equal to 12. This is less than 12. So it's going to be false, and then true, and true, and true. But this is the point where it switches the boundary. the boundary of where it switches, where computing this expression starts out being true and switches to false, or starts out being false and switches to true. So that's where you should test. So you should be able to identify the boundary conditions for testing that. And it's something like this, okay? You probably don't need this. Maybe you want to put a 10 there, but anyway, so that's why this, it's nice that they show you that, so you should start thinking about it that way. Let's look at this. Okay, so we're reading in a 9 character, changing it to an integer. If it's less than 10, it is less than 10, so let's print G. And then we're going to skip all the others. We're going to skip everything else, I guess. Okay, well, let's try this one here, the hardest one. Okay, it's 29. Is it less than 10? No. Is it equal to 10? No. Is it less than or equal to 30? Oh, yes, it is. H. And that's it. This is the only one that's true. Okay. All right, what's this one? Write an if-else statement with multiple branches. If the year is 2022. All right, let's just start like this. Copy, and I'm going to paste it right here. And whoa, let me just, every statement is on a line by itself, so I can do this. If it's that true, then that. Elif that, then that. Elif that, then that. Else that. Okay. So if year, lowercase I, if the year is equal to 20, if it's greater than or equal to 20, it's greater than or equal to that, then print distant future. Elif L year is greater than or equal to 2000, greater than or equal to 2001. What happened? Is greater than or equal to 2001. Then do this. L greater than or equal to 1901 colon, print this, else lowercase e colon, I just colon, that's everything else. And you don't really have to indent. I don't think you really have to indent. Let's see if this works. I'm gonna not indent. All right, run. Print. Oh, you got to put parentheses around the prints? Yes, you do. I think in Python 2, you don't have to. But we're doing Python 3. So I'm going to put this, and I'm going to put this. Okay, if it doesn't have a space there. Just work. right, very good. Okay, this one. Write an expression that will print in high school if the value of user grade is between 9 and 12 inclusive. Okay, so our solution goes here. If user grade is greater than or equal to 9 and user grade is less than or equal to 12. I think that's all. Okay, section 4.5. This is more about using these if operators to detect ranges, this is how you can make the ranges more complex. Basically, we're just learning about these logical operators, and you know about them already because you use them in regular day-to-day English and so on. But so here, for example, you know, if two things are true, okay, this is explaining that when we are doing an and, of course, they both sides have to be true for the and to be true. If either side is false or both, then the and is false. Now, for oring, it's different because only one side has to be true. They both can be true, but only one side has to be true for it to be true. If it's only false if both of them are false. So that's oring, and you know that. And then you can put not in front of things. Not something that's not true is false, and something that's not false is true. All right, so you know, okay, what x is 9, y is x is 7, y is 9. Is this true? Okay, so for and, okay, well, first of all, this is x is greater than 5. Yes, x is greater than 5, so that's true. Okay, so for ands, as soon as if this one ends up being, well, let's see, this is true. So then we look at this one. This is true. They're both of these are true. Here is x greater than 10. No, it's not greater than 10. X is 7. So we already know it's false. We don't even have to look at this. Okay, so it's false. And with this one, is x greater than 10? No, we already know it's not greater than 10, so it's false. Oops. Oh, I'm sorry. 4. Okay, so it's false. So this is false, but is this true? Yes, it's true. So that's why it's true. All right. So for ors, only one of them has to be true. All right. So anyway, you can make sure you understand those. Here, first we see if this is true or not. It is not true. So this is false, but this makes it true. So is this true? Yes. Okay, so this is how you can detect ranges. Or this is the expressions that you can use to detect ranges. So this is which approach uses a logical operator to detect if x is in the range of 1 to 99, inclusive. I think this one does. Is x greater than 0 and x less than 100? Is x greater than 0 and x greater than 100? No, that wouldn't work. X is greater than 0 and x, I'm going to say this one. Okay, I'm wondering why this one's not the right answer. The math notation does not involve the logical operator. Okay. Oh, yeah, it has to involve an and or an or. That's the logical operator. Okay. All right, very good. What's next? Well, here's just some examples to make sure you understand it. And so if days logged is greater than 30 and less than 90, so is days dog greater than 30 and I guess. Is that what we're supposed to do? Yeah, okay. That's what that is. Num dogs has a minimum of 2 and a maximum of 5. Has a minimum of 2 and num dogs has a maximum, has got to be less than or equal to 5. All right. It's nice to execute these things. You can mess around with them. You can look at that. And there's a challenge. Write an expression that prints eligible if the user age is between 18 and 25 inclusive. And that's it. All right, if user age is, I'm going to try this first because I thought this might work in Python, but I'm not sure. It does not work in Java. If 18 is, if user age is greater than or equal to 18, I'm sure this isn't going to work, but user age is less than or equal to 25. I want to see if this works. Recruits. Wow, that's pretty cool. Pretty sure that doesn't work in Java. I'm gonna have to check that. All right. So anyway, of course, that's not what they want you to say. They want you to say if this. Let's copy this. If this and this. That's what they want you to say. I think. All right, so anyway, what's next? 4.6, detecting ranges. Okay, this is like just more of the same. So here we're going to say that if the age of the person is less than or equal to 12, then they get the child discount. Or if the age of the person is greater than or equal to 65, then they get the senior discount. Otherwise, no discount. Everybody else pays 14. And so in this case, we aren't isolating out ranges by, one step at a time. I mean, we aren't doing less than or equal to 12, you get a discount. Less than or equal to less than 65, you get nothing. Else, you get senior discount. See, that's how we would be doing it if we were doing it one of the ways that we looked at before. Here, first we're isolating out the children, then we're isolating out the old people, and everybody else, man, you just got to pay 14 bucks. And so and it might be make more sense to you to express it this way. See, you're seeing there's lots of ways to express code, and this is just might be more convenient for you. You might think of it, better this way. So where you isolate out some things and then everything else is. So you can look at this. In the National Football League, the player positions have jersey numbers in specific ranges. Wide receivers, are those receivers that are like fat or something? Numbers from 10 to 90, 19, or 80 to 89. Select the if statement that explicitly detects the correct jersey number ranges. Okay, so a linebacker is 40 to 59 or 90 to 99. I think I see the pattern there. Okay, so it's 40 to 59 or 90 to 99. That one looks good. What's this one? This is greater than 40. No, that doesn't include 40, so that can't be it. This is greater than, oh, this is 40 to 99. Okay, so it's got to be this one. All right, do the rest of them. Okay, let's do a challenge here. X is equal to 6. If X is less than 6 or greater, and okay, that's got to be, it's not less than 6 or greater than 1. It's not 5 or 4 or 3 or 2. It's not one of those. It's, so we print B here. All right, let's do the hardest one. Okay, X is 8. Okay, first of all, this not goes around the whole thing. It's the not of that. It's the opposite. It's the not of that. So so X is equal to 8. Is this thing there true? Ah, yes, it is. What's inside the shaded area is true because X is equal to 8, and the first term here is X greater than 6. Yes, it's true. And since it's an OR, the whole thing is true, but we're nodding it, so that means it's false because this is true. So this whole thing here, it's false. So we're not going to do this. We're going to do, well, let's see. We got to test this now. That's why it's the hardest one. Is X greater than 2? Yes, X is greater than 2. Is X less than 9? Yes, X is less than 9. So I guess we're going to print B. B. Either way, we're going to print C. So I could have put C here to begin with, and then above C could be A or B or nothing. Anyway, I think this is the answer. Let's see. Okay, 4.7. Detecting ranges with gaps. Why don't we just do it? Oh, what? Oh no, 4.7. Detecting multiple features with branches. Okay. All right. So I don't need to do. I just did. Okay. So here, sometimes a programmer has multiple statements in sequence, which looks familiar to a multi-branch if-else statement, but has a very different meaning. All right, let's see what they're talking about here. Yeah, I actually have a meeting right after this. Forgot. All right, so note that if more than one if statement connects. Oh yeah, okay, sure. Okay, so now we're going down the line, and more than one of them can be true. See, these are all distinct if statements. This is independent of this one, and they're all independent. So it's possible that more than one of these will print out. So in fact, if someone's 26, then this will not print out. This will print out, and this will print out, and this will print out, but this will not print out. Okay, that's what this is trying to show you. So here, if num boxes is equal to 0 and number of apples is equal to 9, this is going to execute. This is going to execute also. So numbox is this, and then this is going to execute. So I think numboxes is going to equal to What are we supposed to write? Oh, final value of num boxes. So I would say, oh, this subtracts 1 from it. 3 minus 1 is 2. So I'd say 2. All right. Here's a challenge. Enter the output for the multiple if-else branches. Okay, so num items is equal to 5. Is this true? Yes, it is. So I'm going to print an A there. So since that's already true, that we're going to skip this and we're going to skip this, and all we print is the P. Okay, because this first branch was taken, that automatically means neither of these are going to be taken. All right, so let's do another one here. Write multiple if statements. Okay, great. I just did this one. Copy this, and I'm going to put it here. And I'm going to say if car year is less than 1968, then do that without quotes. If elif car year oh, no elif, just if car year is if car year is after 1971. Okay, so if car year, I'm gonna put that here. And I'm going to change the after to greater than. And I actually think, and I'm going to cheat, I'm just going to put colons here. I'm pretty sure I can just put colons there. I don't think I have to put it on the next line. I like minimal, I don't want these periods here. See if this works. What am I missing? Let's see. If car year is before 1968, it does that. If car year is after 1971, print that. If car year is after 1990, print that. I wonder if it is my indenting, my trying to be fancy. Line 5. Yes, I was trying to be fancy and I should not try to be fancy. Oh, try again. So, all right. Okay. See if this works. Okay, input of 2001 should say am I typing something wrong? Can anybody see? I got to go to my other meeting. Okay, so if this says, if I input Okay, where's the first one that's wrong? Okay, well, I got to go to my other meeting. Oh, I'm sorry. Someone is probably telling me here. Hold on. Oh, yes. Wait. Oh, yes, we need the parentheses. Thank you. Thank you, both of you. Yeah, I am getting everything mixed up yet. I got to think about how to keep this happening, because actually, this is not a language of, this is not a difference between languages of Python and Java. This is Python 2 and Python 3. And so is this better? My chat box is kind of messed up. Yes, thank you. In my chat box. Okay, so thank you both. My chat box is huge like this, but all right. Very good. So thank you. And I'll continue this next video. All right. Okay, so thanks for watching.